that doesn't have a true inverse. We may have to limit or restrict their domain to give us a true inverse. For instance, and something we're going to look at first is your parabola. Your parabola, does this pass the vertical line test?
Yeah.
Yes. Does it pass a horizontal?
No.
No, because its inverse is going to look like this. The inverse is a reflection over the y equals x. Interchange your x and your y, but to be a true inverse, to be really considered an inverse, it has to pass a horizontal and a vertical test on your original function. So sometimes we have to limit these. Now, we're going to graph this on your calculator. However, you know how to graph this. This is your parabola. Where is the shift? You tell me. To the right, and then where? 4 down. So should I get a parabola that looks like this? Right? What should this vertex be? To -4. We moved over 2, we moved down 4. Isn't this your transformations? Okay? So if you put this in your calculator, you will see a parabola. You will see a parabola that opens up. Okay. And our vertex point, if I didn't know what my vertex was, how would I find it on my calculator? Minimum. Is this an absolute minimum or a relative minimum? Absolute. So say I wasn't keeping track of that, and I wanted to find this, I can find my absolute minimum here. Minimum, go to the left of this guy, it is. Go to the right of it. Okay, yes. And there's my minimum. Yeah, this acts a little strange, that 1.99999, that's a 2. So 2, -4 is my turning point. At 2, -4, I want to cut this graph right here, because this right here makes me fail a horizontal line test. So this part right here is considered the decreasing. This part, the increasing, right? We have a decreasing and an increasing. So we're going to cut it right there. This had all real numbers. Your decreasing part went from -infinity and stopped at the 2. Your increasing part went from 2 to infinity. Well, 2. Those were your increasing and your decreasing parts. We're going to restrict your domain to the increasing. To have a new domain from 2 to infinity. So all we want to look at is this piece right here. We want to look at that piece. We want to find the inverse of this piece. Now the inverse is a line that is a function that will reflect over the line, y equals x. So here's our y equals x line. A good way to start, even without the calculator, is to say, what's this vertex point? If I interchange it, what will my new point be when I reflect it? -4, 2. So I'll be here at -4, 2. And I should see my graph go like this. Shouldn't my graph look like that when I'm done? Now, on your calculator, we can restrict this. We can say, we did this on your thing yesterday. We can say only do from 2 to infinity. X is greater than, we did it with a math test, greater than or equal to 2. Okay? And we graph this guy. I don't know where this piece comes from up there. I think this might be, I'm not sure where that piece is coming from, but for some odd reason, this is the one we want to look at. It might be my drawing first. Oh, no, it's still there. I don't know where that piece is coming from, but this is the piece we want. If I do a draw inverse on this, number 8, and I tell it y1, bears, y bears, it's a function, it's in my y1, it should draw me this piece right here. See this piece right along here? There's my inverse. There's this my original, there's my inverse. Here's my line, y equals x. See it? That's the guy I want, my inverse. So when I do this, and I find the sketching is far easier than to put it on your calculator, because you can take this point and interchange this point. So now we're going to find the new equation for this. Now, because we restricted this, sometimes the equation works where we have to find the domain and the range, and sometimes not. Our range went from, what was our range for this guy? The original. Good. -4 to infinity. Okay, so let's find the inverse equation. The inverse equation, you start with your y, you interchange your x and your y. And you have to solve for y. So isolate the y, add 4 to both sides. And how do I undo a square? Square root. Now remember, when you have a square and you undo it, you always get a positive and negative, don't you? So when we undo this square, this becomes positive and negative. Up my extra, so this is almost like how you branch a circle, remember? Okay, now all we need to do is x to the other side. So plus or minus x plus 4 plus 2 equals y. We're going to take your y and we're going to put f to the -1. I'll rewrite it up here. Now, because I took the increasing part, I think I should take the positive or the negative of this. I'm going to get 2 legs, so I should take the positive of this. So here is my inverse. Right here. I took the positive leg. If I wanted the negative leg, the other one, if I wanted the decreasing part, I would take the negative one. So let's go back to your calculator, and let's go to y2, and put your equation in. Put your equation in with the bubble on it. And it said radical x plus 4 and outside of it said plus 2. Now, my draw inverse is still here. See along my draw inverse line? See my line coming? Right there? Here's my inverse. Isn't that the same as your calculator drew? That's my draw inverse for that guy. It's a true inverse. Does that segment right here, does it pass a vertical line test, this guy? Passes a vertical line test. So it is a function. I had to make my original function, which did not pass a horizontal line test. I had to restrict it so that I could find its true inverse. Okay. I mean, you can also do this to the decreasing side. If I say find me the decreasing side, same thing. Only now we're looking for this one. We're looking for it to go here. And it's going to end at 2 -4. Again, when you flip this around, you're going to be at -4 too. And it's going to go like this, or however it's going to go. It's certainly not going to look like as bad as mine. And it's going to look like this, like -4 too. And it'll go like that, so. And you'll do your negative one. Won't you? Your negative 1 will be this way. Like that. You'll give me the negative 1. And you'll see its reflection. But the idea is you have to restrict this. Okay? Now, we don't always have to restrict to an increasing. We can restrict to a decreasing. And again, when we do this, this one worked out okay. We can spot the domain in the range. We have no problems with this. But just so that you remember, once we do this, your domain becomes your new range. Your range becomes your new domain. We didn't have to worry about that because it is that little piece and that's fine. Sometimes it's part of another bigger thing and you have to restrict it. Does this make sense, restricting? Okay, so let's do one where we restrict to the negative side. What kind of graph do you think this is going to be? Absolute value. It's got some transformations in here. That 3 affects your horizontal shift. It's like an A over B type thing. But it's horizontally moving to the left, and then it's moving up to the up, increasing up vertically. What quadrant should this end up in? 2. So let's put this in your calculator. In fact, let's see if it does. So let's clear everything out that we did. And let's put in absolute value. You find math, go to num, you find your absolute value. On your new calculators, it gives you the bars. On your old calculators, it says ABS parentheses. Either way, it does the same thing. So we graph this guy. And we see it up there in quadrant 2. Now, I'm really not sure what my minimum point is, because the 3 has an effect when it shifts over to the left. So how do I find that minimum point? Minimum. So let's do minimum. Second trace, we go to minimum. Is this the absolute minimum or the relative minimum? Absolute. Good. Okay, right? And here's my absolutely the most minimum point. Negative 0.667, which negative, well, 0.66666. Anybody know what fraction that is? 2/3. And now do you see where that comes from? The 2 divided by 3. That's where your shift came from, 2 divided by 3. This had a different effect, right? Because it was inside here. So this was your 2 divided by 3 shift. Your A over B shift, your B over A shift. So we can find this guy on here. And this is 5, even though it acts a little bit strange, it is 5. So your original graph looked like this. With a vertex point of, I'm just going to say negative 2/3, 5. Okay, or it's negative 0.667, 5. Now we want to restrict this time to the decreasing part. Our domain is all real numbers. Our decreasing is from negative infinity to negative 2/3. That's the domain that we want. Okay? So we're restricting our domain to negative infinity to negative 2/3. What's the range of this guy? 5. Good. 5 to infinity. We stopped right here at the 5 and infinity. So my decreasing part is looking like this. Coming down here, right there. I like to keep track at this point. Told you I'm not good visually. So that point, when I interchange it, what will that point become when you interchange it? Negative 2/3. So we find 5 negative 2/3 over here somewhere, right? And where's my line going to have to go? Isn't it have to go that way? Does that look like a reflection over the y equals x? Shouldn't that be where my inverse is going to end up? Right? I need to reflect. I take this point and interchange it. I can take any point in my graph and interchange it and make a graph out of this. But this helps me visually figure out where this is going to go. So I know my inverse is going to be here somewhere. And what's the domain of my new inverse going to be? Good. Good. And what's the new range going to be? Very good. Because we interchanged your domain and your range, right? So does that visually look like it works? Yeah. So now, to find your equation, we have to go through a little bit more to find your equation. To find your equation, we're going to start like this. Because we have the absolute value here, you're going to have to also isolate your absolute value. We're going to interchange your x and your y. You're inside of an absolute value. So, okay, we did that. Now we got to solve for y. But we have to follow your absolute value rules. We isolate your absolute value. We subtract 5. I'm going to just reflect this a minute so you can see it this way. Now, absolute value says you have a positive root, you have a negative root. Which one do we want? The negative. Good. So we want the decreasing. If we wanted the positive root, we pull out 3y plus 2 equals x minus 5. But because we want the decreasing one, we want the negative root, we're going to pull out 3y plus 2 and set it equal to the negative of x minus 5. We have two roots in an absolute value. So 3y plus 2 is equal to negative x plus 5. We still have to solve for y. So we subtract 2 and we divide by 3. Okay, and we remember to put our inverse sign in here. So we make it x to the negative 1. Now, what do you think this is going to give me when I graph that thing? Is there any restriction in the denominator? It's a straight line. Good. It's a straight line. No restrictions, so all the numbers right. But that's not what we expected this to look like. According to this, I'm going to get a straight line that goes like this. But I'm going to have to restrict it to just do that part of the line. Which is why this came in handy, didn't it? So I'm just going to separate this so that you can see the actual line. Negative 1/3 x plus 3. I just separated it. Oh, sorry, plus 1. 3 over 3 gives us 1. Now, when I take this and I graph this in my calculator, just like Rebecca said, that's a line. That's going to give me a straight line. Here's my graph. Remember, I'm just looking at this piece right here. Here's my graph. Coming through. But you told me, restrict your domain to negative 5. Only look at this piece right here. Don't look at this piece right here. Does this piece and that piece look like it's a reflection? It's a little distorted. If I do zoom 6, it probably would look a little bit better. Zoom 5, it would look a little bit better. But that's the piece that I want. It is part of a line. So you have to come back and restrict this domain. We have to say domain 5 to infinity. And that's where you see comma, x is greater than or equal to 5. That's why you see that on some of your who saw x is greater than or equal to 0, x was greater than or equal to 1 yesterday. That's why you see x is greater than or equal to 5. because I need to say only that piece of my domain. I know it's a line, but all I want is this piece. Make sense?